Right guys, welcome to MM211 of the Maths Methods Fortify study guide. Now we've got this graph f dash of x, so y equals f dash of x on this axis below, and we're asked to sketch a possible function f of x on the same axes. So I'm not going to do it on the same axes just because it's going to be messy on a whiteboard, but you'll obviously do this in your book. So first things first to recognize is that f dash of x is our derivative function or our gradient function, right? So what this means is each one of these functions here, so this is a hybrid function, but each one of these functions here represents the gradient of the original function, okay? So if our gradient function is a parabola or a quadratic, what that means is we're actually going to get a cubic for the original function, okay? So because of the way that the derivatives work, if our derivative is x squared, just for argument's sake, actually, you know what, let's say our original is y equals x cubed, then our derivative is going to be 3x squared, right? So if the gradient is a quadratic, then the original is going to be a cubic, okay? So that's the first part of this question. Just for this section here. So given that this is a negative quadratic or negative parabola, we're actually going to get a negative cubic for the original from -4 to 0. Now it doesn't matter where this is on, like, it can be up or down. It just needs to start at -4 and finish at 0, okay? So our gradient is 0 at -4 and 0 at 0, right? And it's a negative quadratic, which means our original is going to be a negative cubic. A negative cubic would normally come like this, so down, up, down. But our gradient has to be 0 at -4. So we're going to start with the gradient here, and it's almost like we're coming down, up, down. Okay, so we're getting something like this, right? So it doesn't matter where, like I said, on the y-axis this is, because it could be anywhere, but just this general shape will get you the mark, all right? So that's this first part done. This second part, this is at -2 on our graph, which means that, and this is just a straight line, which means that the original graph is going to be a linear function with a gradient of -2, right? So we're going to say this is 4, and we're going to go down like this to 2, right? Because this is a -4 rise and a 2 run, which means our gradient is going to be -2, right? Because this is our gradient function, it's going to have a -2. So that's our second mark there, right? This is our first mark. Our third mark comes from obviously our next part. So if our gradient function is a linear, that means that our original function is going to be a quadratic, right? Because it's the next degree up. So our original is going to start at 2 and finish at 6 and have a gradient of 0 at 3. So this is at x equals 3, which will be somewhere here, which means our gradient of 0 is going to be somewhere here. It's a positive linear, which means our derivative is going to be positive quadratic, which means it's going to come something like this. And that's it, guys. So this is your third mark. I know this is a little bit weird, so if you have any questions, please chuck them in the comments below. I could explain a whole bunch of stuff here, but I think I'll just let you guys ask questions in the comments below because that'll just be easier for everybody. So ask away if you're not sure about something, but otherwise, thanks for watching and have a great day.